Perfect. Welcome to this new YouTube video. Today I will show you an interesting technique named shellcode execution via EnumWindows, okay? Basically, in this case, we're using the EnumWindows API function just to execute our shellcode. So basically, here we have our malware development technique database where we upload a new technique each week. And basically, we have a lot of them where basically we can find a lot of techniques, all of them at the moment for Windows operative system as the target, with a lot of categories like shellcode injection, shellcode execution, shellcode injection, and a lot of these, okay? So basically, let's jump to the technique. Perfect. This technique is a technique created for Windows. We just need user privileges, okay? We don't need to be administrators and have easy difficult, okay? Basically, the description is so simple. Execute shellcode in the current process using EnumWindows API function, okay? This simple function, it's from Microsoft, okay? It's a legit function that basically you can find here the documentation in their own Microsoft official documentation, okay? Basically, we just need the windows.h dependence, and we have these two options as a mitigation, okay? Let's check the steps. Basically, are these 5 from here. The first step is define the shellcode, okay? First of all, we need to define our shellcode, usually created with MSF Venom from Metasploit or Donut, whatever you want to use, okay? Then we allocate memory, okay? We use the virtual alloc function to allocate a new memory space where we copy our malicious shellcode created with MSF Venom inside this new memory space. Finally, we call the new Windows function with a pointer to our shellcode to execute our shellcode, and the shellcode will be automatically executed. So basically, let's jump to the virtual machine to see this code in action. Perfect, that's the code. Basically here we have our shellcode created with MSF Venom in this case, okay? And basically we just need to allocate any memory space using the virtual alloc function, also from the official Microsoft APIs. And this, it's important to set as execute read write, okay? In our case, we need write permissions to write our shellcode inside it and execute permissions just to execute the shellcode, okay? An important note here is that you can just allocate the memory space with read-write permissions without the execute one, and then when you have written your shellcode, you can just use the virtual protect function to set your memory space to page read execute, and in never you will have a read, write, execute memory space in your process, okay? That's important to understand. So basically, when we have the shellcode created, we just need to copy our shellcode inside this memory space, okay? We set where we want to copy our shellcode in the first parameter, that it's the created memory space. Then we set what we want to copy, in this case our shellcode, and the size of the shellcode that we want to copy, in this case using the size of function from C++, okay? Basically, at the end, we just use the EnumWindows function to execute this shellcode inside the new memory space. So basically, this shellcode from here is just a calculator application, okay? If you run a Windows calculator, will be the result of our shellcode. So when this shellcode is executed, just as a proof of concept, a new calculator application will be executed. In a real scenario, you will use, for example, a reverse shell or whatever you want to use, okay? So let's just run it. Let's execute, okay? Now Visual Studio is vaulting our binary. And now it's executed here, okay? Here we have the shellcode executed, that is a calculator. So basically, that's the technique, okay? That's a classic technique to execute shellcode in a Windows process. And basically, you need to understand an important thing, that this code will be automatically detected and deleted by Windows Defender, okay? You cannot use your shellcode without being encrypted, okay? In future videos, we will see how to encrypt our shellcode. But basically, when the Windows Defender or any antivirus see this shellcode, your process will be blocked automatically. Okay, so remember to encrypt your shellcode and try to avoid this type of patterns, because antivirus are looking so close to this type of virtual alloc combined with a memory copied and finally executor function. Okay, so perfect. Let's just jump to the next video.